We're on page 2 now, and we're reducing or simplifying these fractions. So remember the little shortcut or property or rule or recipe. Where's the bigger power of x? Where are there more factors of x, so that when we got done canceling, that's where the leftover x's would be. More on the bottom, so we keep x on the bottom, and all the x's on the top would get canceled, leaving a 1, and the number of x's left on the bottom would be 7 take away 4, 3. That was a whole lot of words. All I really did was subtracted exponents, leaving the x where the bigger power was. Oh, I won't talk so much about this next one. Bigger power's on the top, so no fraction for the answer. 7 take away 4, 3. More than one variable. Oh, I'm getting all overwhelmed. No big deal. Just one variable at a time. Bigger power of x is in the bottom. 4 take away 3 is 1. No exponent necessary. Y has more factors on the top, so the y stays on the top. 5 take away 2, 3. There's our answer. Y, let me make that look a little more like a 3. Y to the third over x. And don't get confused when you see the coefficients and the variables in the same exercise. Just do the coefficients the way you've done since, I don't know, 6th grade or something like that. What goes evenly into both 12 and 15? 3 does. Divide this by 3, you get 4. Divide this by 3, you get 5. So we have a 4 on the top and a 5 on the bottom. And the variables we do by subtracting exponents. X to the 7th beats x to the 1st. 7 minus the invisible 1, I get x to the 6th. And the winner of the y is on the bottom. 11 take away 8 is 3. So it's 4y to the 6th on top, 5y to the 3rd on the bottom. To the middle row. Again, coefficients, divide these both by 2. And you get a negative 4 over 5. The bigger power of x is downstairs. 8 take away 3 is 5. So it's negative 4 over 5x to the 5th, or in the back of the book it would probably look like this. They would pull the minus sign out in the front, because it's a negative divided by a positive, which makes the whole number just a negative number. What do I do with this? I get rid of the negative exponent by using the definition that says x to the negative n is equivalent to 1 over x to the n if x does not equal 0. If x does equal 0, then it's undefined. Okay, so this is just 1 over x to the 3rd. Now this is new, and you could do this the hard way. If you want to punish yourself, you could change this to 1 over x squared, and then that would mean 1 divided by 1 over x squared, and that in turn becomes 1 times the reciprocal. You get the answer x squared. And that's the correct answer, and that's a lot of steps. Easier thing to do is, for now, we'll just say this. What happens if I multiply the top and bottom by x to the opposite power? By x to the 2nd power. 1 times x squared, I get x squared on the top. What happens in the denominator? I get x to the 0, which equals 1. And if I have x squared over 1, I no longer need a fraction. Okay? Now, don't get fooled here. Don't do like 3 divided by 3 is 1 or something like that. This is if we wrote this out, and I'll write this out just this once. This just means 3 times 3 times 3 times 3. And this means, exhaustively, 3 times 3 times 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6, 7 factors of 3. So what do we get to do? Cancel, 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 leaving behind 1 on the top. But more efficiently, just like this was, if this was an x, bigger powers on the bottom, 7 take away 4, we get that. And if you leave that like that, that's okay. 3 to the third, though, is kind of smallish. We might as well change that to its equivalent, 27. But either one of these is fine on a test. Okay, although that is slightly preferred. Okay. How can we get this fixed? Use that same idea. Multiply the top and bottom by 5 to the opposite power and see what happens. You get 5 to the 0 on the top. This is 5 to the 1 times 5 to the 2 is 5 to the third. And what's 5 to the 0? That's a 1. 5 to the third is 5 times 5 times 5. That's 125. Okay. This is getting a little more strange. If I multiply the top and bottom by x to the fourth, I'm going to get x to the negative 3 down here. And that would be okay, and I could work with that. But what if I multiply the top and bottom by x to the 7th? Then I get x to the negative 4 plus 7 is 3. And negative 7 plus 7 is 0. And of course, this is just a 1. So my final answer is x to the third. Now, I want you to notice something now. I think you're ready to hear this. If I do this again, here's where we started, right? If I multiply the top and bottom by 5 to the opposite power, I get that 5 to the 0. Do you notice I could say this in a different way? I could just say, move this across the bar and change the sign of the exponent. 5 to the negative 2 jumps across the bar and becomes 5 to the positive 2, because when you do this multiplication, you always get a 1. See, that happened. Where else did that happen? Right here. The x to the 7th went across the bar. The x to the negative 7th went across the bar and became an x to the positive 7th, and this made a 1. So the thing I want you to notice is, and it could work here too, or we probably wouldn't do it that way, but when we're dealing with negative exponents especially, as long as there's no plus signs in the middle or minus signs in the middle, it's just something times something, you can push a variable across the bar from top to bottom or bottom to top, and what makes it legal is you change the sign of the exponent. And it's too many words to say, but these two examples kind of show why that's okay to do. Oh my goodness, 3 variables. I think I shall faint. Well, 14 and 21, I'm going to divide those both by 7. I get a 2 and a 3. Larger power of x is in the bottom denominator. 7 take away 4 is 3. Larger power of y is in the denominator. 12 take away 4 is 8. And the larger power of z is also in the bottom. 6 take away the invisible 1. You can see the 5th. So it's 2 over, let me write it a little more balanced looking. It's 2 over 3x to the 3rd, y to the 8th, z to the 5th, or in Canada we would say z, or England. Assuming x and y are both not equal to 0, we just have this mess to the 0 power, so it's 1. That is the end of that. And that's the end of page 2.